In this first example of solving a right triangle, we are given triangle ABC, where C has a 90-degree angle square drawn. We are supposed to find the rest of the angles and the lengths of all the sides and round our answer to 2 decimal places. And that's how it's phrased on your homework. The capital letters are always put at the vertices or the corners of your triangle. Lowercase letters are opposite of the uppercase angles. And for example, if angle B is 35 degrees and side B is 4, this angle we can go ahead and write 35 degrees. If you go opposite on the triangle, side B, which will be lowercase, will be here. The sum of all 3 angles of a triangle is 180. So if we take angle A plus angle B plus angle C, that's got to equal 180. Okay, so if we subtract 90, that gives us A plus 35 degrees is equal to 90. Subtracting 35, 90 minus 35 is 55. So we have found angle A. If we want to find side A, I'm going to mark that one in blue. If you go opposite of angle A, you get side A. Angle A was 55. So now we can use our trig ratios to find angle A, side A. If we use 35 degrees, then we're going to need to use tangent, because tangent of 35 is equal to 4 over A, opposite over adjacent. We could also use angle A at 55 degrees because A and 4 are also tangent. And then we can look at it this way: tangent of 55 is equal to A over 4. And I think that's the way I want to tackle it. I'm going to do that in blue. Tangent of 55 degrees is equal to opposite over adjacent. Multiply both sides by 4. And this will give us side A. Now let's be sure that your calculator is in degree mode, because 55 degrees is of course, degrees instead of radians. So I'm going to go to mode, make sure that instead of radian I'm in degree mode, and I am. I'm going to go 4, 10, 55, and to 2 decimal places I get 5.71. Okay. Side C, I'm going to find it in red. Now, since we have A and we know 4, we could do A squared plus 4 squared equals C squared and use Pythagorean Theorem. If we want to use another trig ratio, if we want to use a trig ratio, that's fine too. And one thing about these is you almost have too much freedom. You just have to keep your wits about you. For example, and this doesn't have to be the way you solve it, if I wanted to do cosine of 55 degrees, I could set that equal to 4 over c, adjacent over hypotenuse. I could just as easily choose the 35 degrees and use sine. Sine of 35 is equal to opposite over hypotenuse, 4 over c, and I think that's the way I'm going to take this one. Sine of 35 is equal to opposite over hypotenuse, multiply both sides by c, divide by sine 35, and to 2 decimal places, 4 divided by sine 35, I get 6.97. We have successfully found all 3 angles and all 3 sides. And that's what it takes to solve a right triangle. In our next example, we have another right triangle sketched. Side A is given as 25 in length, and you can put whatever measurement you like. C is 30. Let's get those labeled. A is going to be opposite of angle A, so the 25 will go here. 30 is opposite of C, which is our right angle, and that's 30. Okay, so A is 25, and I may have said 30 earlier when I meant 25, and C is 30. We can go straight to finding angles, or we can find this third side. Anytime you know 2 of 3 sides in a right triangle, Pythagorean Theorem will let you find the third. So we can go ahead and find B. 25 squared plus B squared is equal to 30 squared. When you set up when you set up the Pythagorean Theorem, your equation, the hypotenuse will always be alone and squared. So A squared plus B squared equals C squared. The hypotenuse squared will be isolated. Okay, so let's take 25 squared. That gives us 625. $30 times 30, that's 900. Minus 625, that's 275. And square root. To 2 decimal places, that is 16.58. Okay, now when we go back up here and find our angles, I'm going to try to find a ratio that doesn't use 16.58 simply because that is a rounded answer, and if you ever round a number, you're going to lose accuracy at the end. So I'm going to start with angle A. 25 is opposite, 30 is the hypotenuse, so sine of A is going to be equal to 25 over 30. So that tells us that angle A is going to be sine inverse of 25 over 30. Okay, on your calculator, hit second sine, and that'll invert it. 25 over 30 goes in the parentheses. And to 2 decimal places, I get 56.44 degrees. All right, so we now know sides A, B, and C. We know angle A. The only thing left is angle B. Well, B is going to be 180 minus 90 minus this 56.44. (180 minus 90 minus 56.44), and that gives us angle B is 33.56 degrees. In this problem, we're asked to find the altitude of the isosceles triangle where the common angle on the bases is 16 degrees and the length of the base is 10. The altitude is, for this particular triangle, we're going to draw a vertical line from the top vertex directly down to the bottom and make a 90-degree angle. The base full length is 10, so if we cut that in half, then we've got a 5. From 16 degrees, x is opposite, 5 is adjacent. Which trig function makes good use of opposite and adjacent? That's right, tangent. Specifically, tangent of 16 degrees is equal to opposite over adjacent. Multiply both sides by 5. And let me check the problem. We're asked to round to 2 decimal places. 5, 10, 16. I get 1.43. In this next application, and this is directly from my homework set, an observer in a lighthouse 350 feet above sea level observes 2 ships directly offshore. The angles of depression to the ships are 3 degrees and 5.5. Of course, the figure's not drawn to scale, but it also discloses that on the problem. What we're asked to find is how far apart are the ships and round our answer to 1 decimal place. Okay, now angles of depression would be, say you're standing on an object and you're looking straight out. The angle that you would have to look down to see the object, that's called the angle of depression. So boat 2, the person at the top of the lighthouse, estimates they only look down 3 degrees to see boat 2, and then 5.5 degrees to see boat 1. And we're supposed to find the distance between the ships. So I think I've got it diagrammed out. Ultimately, we're trying to solve for x. I think our game plan should be, and let me mark this as a 90 degrees. We're assuming that the lighthouse is vertical. I think if we can find the distance from boat 1 to the lighthouse and boat 2 to the lighthouse, and we can subtract those distances. At least that's what I think is a decent game plan. All right, so looking at the angle labeled with red, 5.5, if we take 90 and subtract 5.5, that gives us 84.5. 84.5. Let's use that information to find this length. Okay, so from 84.5, y is opposite, 350 is adjacent. Tangent of 84.5 degrees will be equal to opposite over adjacent, multiply both sides by 350, okay, now this is just the y value from the lighthouse to boat 1, 350 tangent 84.5. Alright, so I'm getting, and I'm going to round this to about 3 decimal places just to hang on to some accuracy, 3634.889. 889. All right. Now let's go back up here. The big triangle, the one from the lighthouse all the way out to boat 2, we had an angle of depression of 3 degrees. So that would put this angle at 87, because remember they have to total 90 for a 90 or a right angle. So that would mean that one needs to be 87. All right. Tangent of 87 degrees would be equal, now opposite of that one is x plus y over 350. '87 sweeps out that biggest right triangle, the one that has a vertex at boat 2. Well, opposite of that 87 is both the x and the y length. Multiply both sides by 350. And subtract what we got right above for y. $36, $34. Let me try to make that look a little better. 0.889. And then that's going to give us x. Okay, be careful typing this in. 350 tan 87, close parentheses, minus 3634.889. I get 3043 point, and this problem asks us to go the nearest tenth, so 0.5. And x is what we were looking for, and so x is what we just found. In our last example, a police department has set up a speed enforcement zone on a straight length of highway. A patrol car is parked parallel to the zone, 200 feet from one end and 150 feet from the other end. First, we're asked to find the length L of the enforcement zone, and then we're supposed to find the two angles that are given at the top. The angle where the police officer's car is sitting is a 90-degree angle, And I'm just looking off the diagram that's on my homework set. So let's see, I'm going to go ahead and mark this one as A, this one as B, because we're asked to find those angles. First, let's find the length. Recall that anytime you know two of the three sides of a right triangle, then you can find the third. So the length squared is equal to 200 squared plus 150 squared. The legs squared and added equals the hypotenuse squared. All right, so 200 squared plus 150 squared gives us 62,500. And so L is the square root of that. Square root of 62,500 is 250. Okay, so that's good. That's the first thing we're asked to find on that problem. We can actually get around using that value. I mean, it's totally fine to use it because it's your hypotenuse length. But let's say we want to get angle A. Tangent of A is opposite over adjacent. Tangent of A is equal to opposite over adjacent. So angle A is tan inverse of that ratio. Okay, and just as a reminder, make sure you're in degree mode. Second tangent, 150 over 200. To the nearest two decimal places, I get 36.87. Okay, now we can do the same thing for B. Tangent of B is going to be 200 over 150, opposite of angle B over the adjacent length. Okay, so, B is going to be the tan inverse of that ratio. All right, second tan, 200 over 150, 53.13 degrees. 53.13 degrees. Part B of the problem from the previous slide, just recall that the length of the speed zone enforcement area was 250 feet. Part B of this problem, and I didn't have enough room to do it on the previous slide, we're asked to find the minimum amount of time in seconds it takes for a vehicle to pass through the zone without exceeding the posted speed limit of 30 miles per hour, and we're supposed to round our answer to two decimal places. Okay, so remember, time is distance over velocity. The problem is the distance traveled is 250 feet. The max velocity, if you adhere strictly to the speed limit, is 30 miles per hour. So if you're going exactly the speed limit, now the problem is we need to convert 30 miles per hour to feet per second, because we're asked to find out how many seconds it takes to pass through the speed zone. I'm going to do that under here. 30 miles per hour (1 mile) is 5,280 feet. That'll cancel our miles. 1 hour has 3,600 seconds. 60 minutes at 60 seconds apiece. 60 times 60 is 3,600. And that'll cancel the hours. And that leaves us in feet per second. 30 times 5280 divided by 3,600 comes out to 44 feet per second. Now what we can do is go back up here and we can replace 30 miles per hour with 44 feet per second. That's going to let us cancel the feet and get it just down to seconds. 250 divided by 44 is 5.68 seconds. .68 seconds. And again, that's part B of the problem from the previous slide pertaining to the speed zone enforcement.